All right, next unit we're starting talking about graphing relationships, and your learning target is I can graph relationships and match simple graphs with situations. So first let's talk about a couple of different types of graphs. There's continuous graphs, and those are graphs that are continue, obviously, and they are points that are connected by lines or curves. They're connected by lines or curves. Okay, so what that looks like is kind of like in example 1 up here. You can see how these graphs, they all continue. They keep on going. Okay, so those are continuous graphs. Now the other type of graphs are called discrete graphs, and those are distinct points on a graph. Those are kind of like your dot graphs, where there's no lines connecting anything. There's just a bunch of dots on a graph, and they're not connected in any way. Alright, let's do examples. Example 1 says that each day several leaves fall from a tree. One day a gust of wind blows off many leaves. Eventually there are no more leaves on the tree. Choose the graph that best represents this situation. Okay, so if we look at this, we can see graph A, this gains leaves. So we can see, if I were to write this down here, leaves are growing. And then stays steady, and then falls. Okay, that does not describe our situation, right? So we know graph A cannot be correct. Graph B, we see leaves falling over time, and then leaves falling faster. They start falling even faster. Okay, that kind of describes our situation. It looks pretty close to our situation where it says each day several leaves fall from a tree. That's kind of how it's going over time. And then one day a gust of wind blows and it really falls, right? That kind of looks familiar. Let's just check graph number C real quick. We can see that this falls, leaves fall, stops, and then falls again. Okay. Again, there's nowhere in our scenario does it say that the leaves stop falling or it falls at a same rate. We know that the wind blows a little bit stronger, so that means that we're going to have a graph that is falling, falls faster, and then finally there's no more leaves on the tree. So graph B is the correct answer. For example 2 and 3, we're supposed to sketch a graph for each situation and tell whether the graph is continuous or discrete. Okay, so example 2, it says a truck driver enters a street, drives at a constant speed, stops at a light, and then continues. So let's stop this video and then let's draw a graph. Alright, so you should have drawn some sort of graph like mine. And we know a truck driver, it says that he enters the street. So that means at some point he was completely stopped at the beginning, right? He enters a street and gets up to some constant speed, right? And he starts driving at some constant speed. Then he stops at a light, so that means he has to go back down to 0 speed. And then resumes again, continues again, which means that he goes back up to his speed. So there's some sort of graph should look like this, right? And we can tell if we're going to, remember the second part of this is tell if it's continuous or discrete. This is connected, all the lines are connected and it continues, so this would be a continuous graph. Continuous. So you need to have both parts to answer that question. Okay, example 3 is the same thing. We need to sketch a graph and then tell if it's continuous or discrete. And it says that a small bookstore sold between 5 and 8 books each day for 7 days. So I want you guys to stop the video real quick, draw your own graph, and then check to see if you did it right. Alright, so you should run some sort of graph like this where you have days on the x-axis and books sold on the y-axis. And we know that a small bookstore, they sold between 5 and 8 books each day for 7 days. So let's say on day 1, we're not given the exact amount that they sell, but we know it's somewhere between 5 and 8. So let's go ahead and we'll choose 6 here. On day 2, it sold, let's just say 7. You guys can kind of fill the rest of these out how you see fit, as long as it's between the numbers 5 and 8, right? And so you should complete it something like this, where the numbers should lie somewhere in this range, from 8 below to 5, somewhere in that range there. Okay, so what we can see is that there were not, they didn't sell books in between these times, so we wouldn't actually go ahead and connect these dots. This is an exact representation of the scenario that's given, and we see that there is no lines connecting, so this has to be a discrete graph. There's just points on the graph. And that's how we do graph relationships. So hope you enjoyed it. Take care and